All right, let's get right into it. We all want our AI to be smarter, right? Faster, more accurate. But how do we get it to understand our world? Our internal reports, our private documents, the stuff that makes our business unique. Well, today, we're going to pull back the curtain on the most crucial first step, getting your data ready to build a truly intelligent AI.
So you've definitely been here. You ask a chatbot something about a recent event or your latest project, and it just gives you a blank stare or says, I don't know. That's because most of these big models have a knowledge cutoff date. Their brain is kind of frozen in time, limited to what they were trained on. They have no clue about your private, up-to-the-minute info, and that's a huge problem.
So what's the fix? It's this absolutely brilliant technique called Retrieval Augmented Generation, or RAG for short. And I love this analogy. RAG is basically like giving the AI an open book test. Instead of just relying on what it's memorized, it gets to look things up in a custom library, your library of information, right before it answers. This keeps its answers grounded in fact and super relevant to you.
But, and this is a huge but, that open book is only as good as what's written inside it. And this brings us to the #1 rule of pretty much all data science, and it is especially true here. Garbage in, garbage out. You can't just throw a messy folder of random files at it and expect magic to happen.
And if you don't get this prep work right, the whole system just falls apart. The AI might not find what it needs, or it might totally misunderstand what it finds. Or the whole thing could just grind to a halt when you try to add more data. Seriously, any one of these problems can sink your project, which is why this preparation phase is so non-negotiable.
So that is the big question we're tackling. How do we build that high-quality, AI-ready library? It's not magic, believe me, it's a structured engineering process. And we're going to walk through it, step by step.
The solution is what we call a data pipeline. It's a solid 5-step process. Think of it like an assembly line that takes your raw, messy files and turns them into pristine, organized data that an AI can actually understand and use.
So here's our roadmap. First, we ingest the files. That's just grabbing the PDFs, Word docs, whatever you have. Then we extract the text, just pulling the words out. And after that, we get to the really critical stuff, chunking the text into smaller pieces, embedding them into a language the AI gets, and finally, storing it all in a special database. Let's break down the most important parts of this whole thing.
All right, let's get to the heart of it. The two most critical steps in this whole pipeline are chunking and embedding. This is where we turn that messy human language into the perfectly structured data that fuels the AI's ability to search and find things.
And this right here perfectly explains why we do chunking. Trying to find one specific fact in a giant 100-page document, that's a needle in a haystack. But if you break it down into 300 small, focused paragraphs, well, now it's like having a perfectly organized box of index cards. The AI can just go and grab the exact card or chunk that has the answer.
So why are we so obsessed with these tiny little pieces? I mean, why not just feed the whole document to the model? It's a great question, and it turns out there's a really specific technical reason behind it.
It all comes down to something called the context window, which is basically the AI's short-term memory or its attention span. Models like Llama 2 might have a total window of over 4,000 tokens, but for retrieval, we want to be way more focused. By making chunks around 500 tokens, we're sending a really dense, relevant piece of info to the model, which leaves plenty of room for our actual question and instructions.
Okay, so we've got our index cards, our text chunks. Now we need to translate them so the computer can understand them, and that's where embeddings come in. You can think of an embedding as a universal translator. It takes the meaning of a text chunk and turns it into a string of numbers called a vector. This lets the AI search for ideas and concepts, not just specific keywords. The source material really puts it perfectly here. It's this conversion into a dense numerical vector that makes the whole thing work. See, pieces of text that mean similar things will end up with similar-looking numerical vectors. And that's how the system finds the right info, even if the words you used are totally different.
And this is what it actually looks like. That paragraph about last quarter's earnings, once it's embedded, to the AI, it's just this long list of numbers. It looks like nonsense to us, but for a computer, that vector is a super rich mathematical map of the original text meaning.
So we've done the hard work. We've chopped up our documents into chunks and translated them into these numerical vectors. Now we need a place to put them, somewhere safe and organized. It's time to build our final AI-ready library.
And that library is very often a Delta Lake table. You can just think of this as a superpowered digital bookshelf. It's built specifically to handle the massive scale and the complexities of AI workloads, giving us the reliability and the speed we absolutely need.
And here it is, the beautiful end result. Just look at this clean, structured table. For every single document, we have the original text chunk right next to its embedding vector, all organized. This right here is the foundation of our RAG system. This is that open book our AI is going to read from.
So let's just step back and recap what we've actually put together here. We've built a scalable, repeatable process. We can throw any collection of documents at it, chop them up strategically to fit our model's brain, generate meaningful embeddings, and store everything in a high-performance, AI-ready library. We've literally turned unstructured chaos into structured knowledge.
So the library is built, the foundation is solid, the data is prepped and ready for action. But you know what? This is only half the story. The next huge question is, how do we ask the right questions? How do we get the AI to actually use this library effectively? Well, that's the art of retrieval, and that is the next step on our journey.